Dear students, this is session number 7 on operations management, and in this session we will complete the topic of demand forecasting. These are the contents that we are going to discuss in this session. We are primarily going to discuss the time series methods, which largely have a horizontal component in them, and these are the three main methods under this time series analysis when we are only dealing with a horizontal component. So let us consider the past sales of a product whose future demand is to be forecasted, and it is seen that when we see the time series of the past sales of this product, there is no seasonal component, no cyclic component, no trend component present in the time series, and the only two components are the horizontal component and the random component. And so we know that we do not focus on the random component, we cannot do anything about it, so we'll focus mainly on the horizontal component. So now if this is the case, that we have a demand time series or the past sales time series of a product with largely horizontal component contained in it, and we want to anticipate or forecast the future demand of such a product, these are the three methods which can be used: the simple moving averages, weighted, and the exponential smoothing average. Let us discuss them one by one. Okay, so in the simple moving averages method, the forecast for the next period. अब बच्चों एक चीज ध्यान से सुनिए, मैंने पहले के सेशंस में भी कहा है कि जब आप फोरकास्टिंग करते हैं तो आप अपने आप को मानते हैं कि प्रेजेंट पीरियड है टी पीरियड, और आप फोरकास्ट किसके लिए कर रहे हो? नेक्स्ट फ्यूचर पीरियड के लिए. उस पीरियड को हम क्या मानते हैं? फ्यूचर पीरियड को t+1. सो वी वुड बी फोरकास्टिंग फॉर द पीरियड t+1. and the forecast would be called ft+1. Okay, so in the simple moving averages method, what we do is that we take the n demands values, n sales values, means sales values for the n past periods, and we find out their average. For example, you are sitting in period t. When you are sitting in period t, suppose you are sitting at the end of period t, and you already know from the marketing people, the sales people, that what has been the actual demand of our product in the market in this week. So that most recent demand, the most recent past sales is dt, right? And prior to that period, the past sales value, the demand, was dt-1. And what was the, so for the first most recent period, the past sales, the demand was d, for the first period it was dt-0. For the second period it was dt-1. Similarly, for the nth period it would be dt-n. So it would become dt-n+1. But I again repeat, for the first period it is dt-0 for the first period. So for the nth period, the past sales value was dt-n-1. So that becomes dt-n+1. So this is this dt-n+1 is the nth sales of the product that happened in the nth period in the past. So what we have to do, we have to take n such past sales values, and we take their average. This mean value that we obtain is called the simple moving average. So what we have done, we have taken the most recent sales, the sales prior to that, the sales prior to that, the nth period sale in the past, and then we have found out their average. And then this average or mean that we have calculated, we are assuming that this is the future demand of this product for the period t plus 1. Why are we doing this? Because we know that the demand time series largely had a horizontal component. The data points of the past sales were clustering about a mean value. So we believe that this mean value will continue to be showing the sales of the product, the demand of the product in the future also. So we have calculated that mean value, right? When this t period would be over and we will actually reach the future period t plus 1. When we reach the actual period t plus 1, see, sitting over here, sitting in the t period, we had forecasted for the period t plus 1. But when we will reach the end of the period t plus 1, we'll get the actual demand for the period t plus 1. So this actual demand for the period t plus 1, and this was the forecasted demand for the period t plus 1. The difference is that we calculated this forecast, we made this forecast sitting in period t, and we'll come to know about this actual demand only when we have arrived at period t plus 1. And the difference between t plus 1 and ft plus 1 would be the forecasting error for the period t plus 1, but that's a separate issue. What I'm trying to make you understand is that here when you were making this calculation, you were sitting in period t. The present period was period t. When this period t gets passed, period t plus 1 gets passed and you reach its end, you get the actual demand for the period t plus 1. Now sitting in this period t plus 1, you can forecast for the period t plus 2, and then ft plus would be the most recent past sales values divided by n. But now, what is the most recent past sales value? It is the sales of the present period. So now the most recent sales value, the first sales value that you will take as dt plus 1. So you will have now first value as dt plus 1, and dt, which was the first value over here would become the second, and this was the nth value when you were calculating ft plus 1. So when you are calculating ft t plus 2, you still have to take only n values. So this is now the n plus 1 first value. So you have to eliminate it. So the last value now would not be this. When you are calculating ft plus 2, the last value would be now ft minus 2. So this is the last nth past sales value that you will take while you are calculating this, because this had to be deleted because this had to be added. So again you are taking n values, and now the most recent past sales value when you are sitting in period t plus 1 and you are forecasting for period t plus 2, the most recent sales value is dt plus 1, and the nth past value is dt minus n plus 2. So when you take this average, this is the forecast for the next period. So bacho, this is how when you move from one period to the next period, you keep on computing a newer average by including the most recent sales value and by discarding the oldest sales value. So because you compute average from period to period, because you are calculating a rolling average, this method is called moving averages method. And then students, right, this all I have explained. Okay, I'll explain now that how do we take the value of n, how do we select the value of n. Please, if your demand time series is largely showing a horizontal component, take as large value of n as you can, because if you take larger values of n, you include more past sales values while calculating the mean value, and by taking large number of past sales values, you are able to nullify the random variations to a large extent. On the contrary, if you see that in your demand time series that you are trying to from which you are trying to forecast for the next period, if it shows a slight trend increasing or decreasing, then you should take smaller value of n, because when you take smaller value of n, you are then including only some recent past sales values and you are discarding the older values. So when you are discarding the older values, you are adhering more closer to the trend, right? Because if there is an increasing trend and if you still keep on taking all the past values, the average would be calculated by taking all these past values, and it would nullify the trend that should have been in the future demand that you are trying to forecast. So when you take a smaller n, you include only the most. For example, if you take only 3 past sales value, n is equal to 3, you are only taking past 3 sales, and then you are trying to compute your future forecast by calculating an average which is giving only importance to the recent values which are showing the trend, and you're discarding the older values. So the thumb rule is that when you take a time series, the time series is showing only normal component without any trend, etc., take a large value of n. But if your demand time series happens to be showing some increasing or decreasing trend, take a small value of n. Then the forecast that you would be calculating would be more accurate. So why the name simple moving average? Because you are finding out simple mean, and when you find out simple mean, the weightage that is given to each past sales value is the same. And what is that value? 1 by n. So when you are calculating, sitting in period t, when you are calculating the forecast for period t plus 1, you are taking past sales value dt, past sales value dt minus 1, past sales value dt minus n plus 1. But what is the weightage associated with each of these demand values? The weightage associated is the same, 1 by n, 1 by n. So because the weightage associated with all the past sales values in computing the average, in computing the future forecast is the same, the method is called simple moving averages. Now in the part 2 of this session 7, I will begin discussion on moving weighted averages method. Thank you.